The discovery of 300,000 to 400,000-year-old butchered elephant remains in India represents one of the most significant pieces of evidence for early human hunting and tool use in Asia. This find showcases how early humans in the region were capable of taking down and processing large prey like elephants, possibly with stone tools. Meanwhile, the Narmada fossil of India has garnered interest as a potential Denisovan specimen and may represent the perpetrators of the elephant butchering. The butchered elephant remains are located in the northern part of the country, while the Narmada skull was discovered in the Narmada Valley, which lies in central India, particularly in the state of Madhya Pradesh. Located in the northeast of India, near the borders with Nepal, the discovery site for the butchered elephant fossils is situated close to the Ganges River basin. This discovery includes the remains of extinct elephants from the genus Paleoloxodon, specifically Paleoloxodon turkmenicus, and is accompanied by 87 stone tools, suggesting that early humans used these tools for butchering the animals, likely to extract marrow from the bones. These elephants were much larger than modern Asian elephants, and their butchering suggests that early hominins had developed not only the hunting skills, but also the technological ability to process such large animals. The precise dating of these fossils, achieved through analysis of protein decomposition in the teeth, places them squarely within the Middle Pleistocene, aligning them with other hominin activity in Asia. These fossils offer significant insights into the interaction between hominins and large game, with some researchers suggesting that humans either hunted these elephants, possibly Homo heidelbergensis, or a related human species. However, the question of whether some Homo heidelbergensis fossils could represent Denisovans is one of the most intriguing in paleoanthropology. Homo heidelbergensis, an archaic human species that lived between 600,000 and 200,000 years ago, is considered a common ancestor of both Neanderthals and Denisovans. While no Denisovan fossils have definitively been classified as Homo heidelbergensis, certain fossils historically attributed to Homo heidelbergensis might in fact belong to Denisovans. The butchered elephant site and the Narmada skull may share a broader connection in terms of hominin activity and tool use in the Indian subcontinent during the Middle Pleistocene. Both sites offer key insights into early human behavior, suggesting that hominins in different regions of India were engaging in complex hunting and tool-making practices. Nevertheless, the two sites are geographically distinct, with approximately 800 to 1,000 kilometers, 500 to 620 miles between them. Despite the distance, both sites are important for understanding early hominin activity in India, including their hunting behaviors, tool use, and interactions with megafauna like elephants. The Narmada skull is a Middle Pleistocene fossil, often associated with Homo heidelbergensis or Homo erectus. The Narmada skull exhibits a mix of robust and gracile features. While it has a large brain case and pronounced brow ridges, its overall skull structure is somewhat gracile, which has led to the suggestion that it might represent a female. The lack of robust, masculine traits commonly associated with male hominins of this era supports this hypothesis, though conclusive evidence, such as pelvis shape or other skeletal markers, is lacking. The fossil could be of a robust female aged 25 to 30 years, which is significant because females have a smaller average brain size, about 10% less than males. Nonetheless, she would be one of the most robust ancient females in the fossil record. However, the skull's close affinities with classical Neanderthals are more surprising and difficult to explain unless through hybridization. Indeed, the Narmada Valley's mid-intercontinental location as a possible crossroad or corridor of early hominin migrations raises the possibility of hybridization. This is the most likely reason why the Calvarium features a mosaic of characters. Its distinguishing features may be explained by significant local evolution following hybridization, as occurred among the Neanderthal group of hominins in Europe. Truth be told, people think in paradigms, which is why efforts have been made to assign these fossils to known human groups, such as Homo sapiens, Homo erectus, Homo heidelbergensis, and Neanderthals. In paleoanthropology, sex determination based on skull morphology is difficult, especially in fragmentary remains. However, certain features, such as less pronounced brow ridges, smaller cranial size, and more rounded facial features, can be indicative of a female individual, particularly when compared to more robust male counterparts. Gracile skulls often have more delicate features, potentially indicating female individuals, whereas robust skulls, with thicker bones, larger brow ridges, and more pronounced muscle attachments, may indicate males. For example, but the Narmada fossil displays enough gracile features to raise the possibility that they could represent a female. As stated, the Narmada fossil has garnered interest as a potential Denisovan specimen, particularly because Denisovans are believed to have ranged across parts of Asia and possibly West Asia. Since the fossil comes from a region where Denisovans or their relatives might have lived, there is speculation that it could represent a Denisovan or a population closely related to Denisovans. However, without DNA evidence from the fossil itself, this remains speculative. Another possibility is that the Narmada fossil could represent a relative of the last common ancestor of both Neanderthals and Denisovans. The Middle Pleistocene is thought to have been a period when the ancestors of both these groups were diverging. Given the fossil's age and location in the Levant, an area that might have been a meeting point for different hominin populations, the Narmada specimen could be a late representative of this population after the Neanderthal-Denisovan split. Alternatively, many researchers continue to argue that the Narmada fossil represents a regional form of Homo heidelbergensis, an ancestor of both Neanderthals and Denisovans. The skull's features, such as the thick cranial bones and large brow ridges compared to modern humans, are characteristic of other Middle Pleistocene hominins, though they do not match exactly with known Neanderthal or Denisovan features. There is no direct genetic evidence linking the Narmada fossil to Denisovans, but given the expanding understanding of Denisovan range and influence, it remains a possibility under consideration. For now, the Narmada fossil's exact place in the human evolutionary tree remains unresolved, but future DNA analysis or comparisons with more Denisovan fossils may shed light on whether this ancient individual was part of the Denisovan lineage, a common ancestor, or another group altogether. The absence of Denisovan fossils could be due to several factors, including the fact that fossils do not always preserve well in every region. The Denisovans may have lived in environments where fossilization was less likely. Denisovan remains might exist, but could be misidentified as belonging to Neanderthals due to the close genetic relationship and morphological similarities between the two species. Without DNA analysis, it can be difficult to distinguish Denisovan fossils from those of Neanderthals or other archaic humans. Nevertheless, some researchers suggest that fossils from South Asia could represent Denisovans or hybrids. The mystery of Denisovan fossils in Asia highlights the complexities of human evolution and the interconnectedness of ancient populations. Denisovan fossils may still lie undiscovered in Asia or other archaeological sites. More intensive excavation and analysis of existing fossils, particularly through genetic testing, could eventually reveal Denisovan presence. Marine isotope stage 13 spanned the interglacial period from 524,000 to 474,000 years ago, with a peak around 500,000 years ago. Scientists believe that the epoch is significant because it marks the first evolution of anatomically modern humans, known as Homo sapiens, and Neanderthals, known as Homo neanderthalensis. According to current evidence from fossils and DNA, the Neanderthal and modern human lineages diverged at least 500,000 years ago. It was once believed that Neanderthaloids evolved from the East Asian strains of Java man and Peking man and spread along the foothills of the Eurasian mountains into Europe during a lush interglacial period, a theory that has now been proved false. Nonetheless, this interglacial period, now referred to as marine isotope stage 11, was during these relatively short interglacial periods that early humans seemed to thrive and expand into new regions. Marine isotope stage 11 was an interglacial period that began 424,000 years and ended 374,000 years ago, centered around 400,000 years ago. This interglacial provided one of the richest records of human occupation, and likely achieved temperatures slightly higher than today, with a slight rise in sea level, perhaps 10 meters or 30 feet. Investigators discovered that after hundreds of thousands of years of stability, dramatic shifts occurred around 400,000 years ago, with extreme swings between wet and dry periods, lakes shrinking and new types of vegetation regularly replacing large grasslands. 400,000 years ago, the Near East experienced extreme environmental changes. Fresh water evaporated on a regular basis, and vast grasslands vanished, along with the large grazing animals that early humans hunted. However, ecological instability did not drive these humans out of the area or extinguish them. Instead, it prompted them to significantly alter their behavior and culture. Early humans improved stone tools and weapons, expanded trade networks, and even demonstrated the evolution of symbolic communication. Around 300,000 years ago in South Asia, a small group of technologically advanced humans dragged home and dismembered a plethora of wildlife. They hunted and butchered a wide range of prey with exquisitely pointed flint spearheads and blades, including gazelles, deer, and the now extinct aurochs, the ancestors of modern cattle. In the coastal plains' cool, humid climate, these early humans foraged for acorns in nearby oak, olive, and pistachio forests. They ate the saline leaves of shrubby saltbush and carried ostrich eggs back to the cave, slurping on the yolks. Could these early humans have been Denisovans? And with that tantalizing statement, we leave you to ponder the mysteries of our shared human history. Until next time, stay curious and stay questioning. And before you go, please subscribe, share, and explore our channel's other videos. Thank you, and take care.